In a previous video, we saw that if you have an electric current carrying loop, then it generates a magnetic field that's very similar to that of a bar magnet. But it doesn't quite resemble a bar magnet because if you look inside the bar magnet over here, then you can see that there is this long region where the magnetic field is pretty straight. It's not exactly straight, but pretty much straight and parallel to each other. Can you see that over here? However, if you look at our artificial magnet over here, then notice that this region where the magnetic field lines are straight is very short. And so this resembles not a big bar magnet, but a very tiny bar magnet. So now the question is, how do we create something that generates a magnetic field perfectly like a large bar magnet, where we have a large region where the magnetic field lines are pretty straight inside? That's what we should find out now. So how do we do this? Well, what if we bring in another current carrying coil over here? So let's say we bring in another current carrying coil and place it down here somewhere. Then it's identical to this one, so it's going to produce an identical magnetic field of its own. And I'm going to show that in a different color over here. But remember, magnetic fields can never ever intersect. And so the total magnetic field of these two coils together won't look like this because they're intersecting. So you know what's going to happen? The two magnetic fields are going to merge together and give us a new magnetic field that's going to look somewhat like this. Ooh, look at the combined magnetic field. We now have a straight region over here. We also have a straight region over here, but in between it's kind of bulky. So how do we straighten this out? Well, I'm pretty sure you can guess now. Let's add one more current carrying coil in between over here, and let's see if it straightens out. So if we introduced another current carrying coil, again, it's going to generate its own magnetic field, which I have shown in another color. And I'm pretty sure it's looking like a mess right now. But again, the magnetic fields don't ever intersect. So now this magnetic field will merge with the previous magnetic field, and together the magnetic field of all the three coils together is gonna look somewhat like this. Hey, look at this magnetic field. We are getting close to what we want. But again, we have these little bulging out regions. We have little wings over here. And I'm pretty sure you know what to do next. Well, just keep adding more and more coils in between. So you know what? Let's go crazy. Let's say we add 50 coils in between. I'm not going to show all the 50 coils. I'm just going to show only few one. But let's imagine we add something like 50 coils. I'm pretty sure you can guess what's going to happen. The magnetic field inside is going to become almost straight now. And these regions are also going to straighten out. And so the new magnetic field of all these coils together will look like this. And ta-da! We have done it. This looks exactly like what we wanted. So if we have lots and lots of current carrying coils, then it resembles a bar magnet. Now, of course, to make this construction easier, instead of taking different loops and keeping it on top of each other, we could take a single wire and then coil it like a spring to give us multiple loops. Somewhat like this. So you have taken a wire, you coil it multiple times and pass current through it. And since we are getting a magnet due to electric current, we call such magnets electromagnets. And this particular electromagnet, which has a shape like a pipe or a tube because of so many coils, we give it a name. It's called a solenoid. And the word comes from German Solen, which means pipe, and oidus, which means shape. So whenever you coil something so much that it looks or resembles like a tube or a pipe, we tend to call it a solenoid. And when you pass current through it, it behaves like a bar magnet, where one side of it acts like the North Pole and the other side acts like a South Pole. And guess what? Electromagnets have great advantages over permanent magnets. You see, as the name suggests, these have their magnetic fields permanently fixed. You can't change them. But in electromagnets, if you increase the strength of the current, you can increase the magnetic field strength. If you switch off the current, the magnetic field disappears and the electromagnet gets turned off. If you reverse the direction of the current, the magnetic field will reverse, and as a result, you can reverse the poles. So it's very versatile in the sense you can control its magnetic field. But the only disadvantage is that if you want to use it for a long time, you have to continuously supply electric power to it. It runs on electricity. But if you are to use permanent magnet for a long time, go ahead, it's free of cost. So depending upon what we want, in some cases, like in MRI machines, in magnetic trains, where we want to keep changing the magnetic field, we're going to use electromagnets. But in some cases where we don't want the magnetic field to change, it makes perfect sense to use permanent magnets over there. And lastly, we can make electromagnets way stronger by introducing a soft iron rod. You see, iron is a magnetic material. This means when you place it in a magnetic field, it gets magnetized, starts behaving like a magnet, and adds on to the magnetic field already generated, making it much stronger. But soft iron, the word soft here does not mean it's soft like a pillow. Soft ions are kind of ions that can be easily magnetized, and when you switch off the current, they will easily demagnetize. They're sort of like temporary magnets. That's what we need over here for electromagnets, right? But there's another class of ion called hard ion. These are the ones which are extremely hard to magnetize, but once you magnetize them, they're extremely hard to demagnetize as well. These are the materials that we will use for making permanent magnets. So, what did we learn in this video? We saw that if you take a wire and coil it many times around to make a shape like a pipe, we'll call it as a solenoid. And when you pass current through it, it generates magnetic field very similar to that of a bar magnet. We call such devices electromagnets. And by introducing soft ion, a kind of ion that can be easily magnetized and demagnetized, we can enhance the magnetic field and make the electromagnets way stronger.